Hi everyone, and welcome to electricity lesson number 3, where we're going to learn about circuit simulations. So this is going to be the first part. Today is just an introduction so that we get familiar with the circuit simulation program that we're going to use, okay? And so first of all, you may not know what a simulation is, so can everyone please say simulation? Okay, so a simulation, and I'll just give you a picture of it, okay? So in real life, we could get light bulbs and batteries and wires, and in class we would do that, okay? But you can also do this virtually online by using a computer program. So a simulation pretends as if these parts were all real, and then it will behave itself in the same way as real life. So for example, if I connect everything properly, the light bulb will light up. Okay, alternatively, if I, for example, connect everything properly, but open my switch means when it's open, it means that the gate is open, and that means that the circuit is incomplete, and then the current will not be running through here. So notice that the light bulb has turned off, okay? And so that's what a simulation helps us to see. Okay, so we're going to be using a simulation program from phET out of the University of Colorado. We're going to get familiar with it a little bit, just get our hands on it, and you can actually try it out for yourself as well. And then after we practice a little bit, you can do a quizzes assignment on good and bad circuits, okay? So the learning goal today will be to, by the end of the lesson, you're going to understand how to hook up an electrical circuit to light up a light bulb. So kind of like you're going to hook it up properly. And then you're also going to learn about electric hookups that will not work properly. Okay, so I want you to distinguish between good circuits that will make a light bulb light up and bad circuits. That means that the light bulb will not light up. Okay, so let's just try this out. Okay, so everyone, if you would like to, you can actually just follow along by actually running this program. So please go back to the PDF if you'd like, and you can click on this link right here under phET simulation practice. Okay, and it's totally up to you if you want to watch me for the entire lesson first and just watch the video before you try it out on your own, or if you would prefer, you could also try this out and pause my video as you're going through it. That way you can kind of get like step-by-step instructions. Okay, so this is the phET simulation website. I looked up the software requirements, and it seems as though I'm hoping, as long as everyone has like the latest version of Google Chrome or Safari, okay, and whatever, okay, I'm hoping that your devices will just automatically be able to work. Okay, so you're going to click on this website. Sorry, you're going to click on the website, and then after that, there's a big play button right here. You just click on that. Okay, and then over here, we're just going to use intro. Okay, we're not going to go into lab. We're just going to click on intro. Okay, so here is our program, okay? And so what we would first always do is we have to grab some batteries. So there's a bunch of different items over here, okay? But we're just gonna today focus on these top ones. And then tomorrow, next class, we're gonna play around and see what is conductive and what is not conductive. Okay, and so here we are. Let's take a look at this. Okay, so the first thing we always need when we are doing a circuit is to have a battery or a source of energy. Okay, so in this case, we have batteries. Next up, we also need conductors. Okay, so a conductor could be a wire, for example. Now, just as a side note, if you ever wanted to like get rid of something, let's say you pulled this over and you have too many items, you just have to click on the item and then click delete, or press delete on your keyboard. Okay, but you're just dragging these over and dropping them in. Okay, now notice that, let's just say you didn't connect it properly, like they weren't touching. If they aren't touching, that means that there's no contact, and that also means that there's no circuit that's going to form properly. Okay, so that would be an incomplete circuit. But if there's a gap here, that would be incomplete, and then the light bulb would not turn on. But if I make it touch to each other, notice that they kind of like snap together, like they're magnets almost. They're not magnets, but it snaps together like that, okay? So you want all of your pieces to snap together. So notice that the wires can also be lengthened or shortened, okay? So I'm going to drag that over. I like to make my circuits into nice rectangles, okay? So I'm just going to go like this. Then I'm going to pull this wire over here. I like to make them into rectangles just so that they're neat and tidy. So I want to do one more this way and then make it go down this way. Okay, I'm going to make it into a nice box. Then over here, I'm going to make it into another box. Okay, here's my light bulb. Oh, notice that I didn't connect it properly. So I'm just going to drag one of these ends and bring it over. Okay, now next up, I'm going to go like this. Okay, and so what I have to make sure of is that this wire connects with one side of this light bulb, and then the other wire makes contact with the other side of the light bulb. Okay, so there's like a left part and a right part, or a start and a finish. The electrons that are flowing through will go along the wire, and they'll actually go through the filament, the little wire that's in the light bulb, and continue on over here. Okay, so here is an example of the simplest type of circuit you can have. Okay, so this is great because it's lighting up. That means my circuit is complete, and that means that my light bulb is turning on. Okay, let me just show you a very, very common mistake. Okay, so a common mistake is that sometimes students will accidentally, rather than connecting the wire to the other side of this light bulb, they'll actually just connect it to the one point right here. Okay, so notice that the electrons are flowing, but notice also that this light bulb is not lighting up, interestingly enough. Okay, now what we have here is called a short circuit. Okay, so the light bulb is not turning on because all that's happening is that the wire is connecting to the batteries. It's not connecting through the light bulb, and the electricity is running through this, and nothing is being used up. The energy is not being used up. So when that happens, it will actually overheat the battery. Okay, so I can, if we were in class, I would show you some other videos of like short circuits and how to ruin your batteries. Okay, but let's not worry about that today. Okay. So we don't want this to happen. If you find that your batteries are on fire, it means that one of your connections are a little bit funny or a little bit off, okay? How do we make this better? Well, I've got to connect this wire over to here. So I'm going to click on this joining part. Okay, I'm going to cut the connection, and then I'm going to reconnect it properly. Okay, so one of them is going to be on one side, and then the other one will be on the other side. Okay, so as I mentioned, this is the simplest type of circuit. Okay, now I'm just gonna, so I hope everyone can just, if you want to pause the video and try this out, okay, you can just follow exactly, and you'll notice that over here, I have screenshots of the exact same thing, so you can follow it by just checking back over to the PDF as well, okay? Next up, I want to try out putting a switch in, okay, just kind of like a light switch, so we're gonna try that one out as well. Okay, so let's go back to the simulation. So what we could do is just reset everything. Okay, so here I can click on this reset button, which is on the bottom right hand corner. So let's just reset it. It just wipes everything clean, and let's just start it up again. Okay, battery, okay. And then I'm still going to put a wire here, okay, just so that, okay. And then I'm going to put in a switch. So this is just like a light switch. Okay, this is just like a light switch. Now, oh, I almost forgot, okay, and I'm gonna just do this. I'm gonna continue on with this, okay. I'm gonna put one more wire right over here, my light bulb, my wire here, and then I'm just gonna finish this off, close this off, okay. So, okay, let's look at this. Now, why isn't this light bulb turning on? Does anyone know why? Okay, it's because this switch is open. So this is almost like saying you've turned the light switch off. Okay, that means it's open. But what I could do instead is I'm going to switch it on. So I click on the switch. Okay, notice that when I click on the switch, it closes it. And then that means that when I have a closed switch, my circuit is complete. Okay, now if I click on this again, on my switch, that means that is now open. So open, closed, open, closed. Okay, so open switch means off, closed switch means on. And I noticed that a lot of you did really, really well on our last quizzes assignment. You did so well. Okay, now just as a side note, I almost forgot. So when I click over here, then it unselects. Okay, so if I wanted to click on it again, I can just click that. Okay, now I just wanted to mention also that instead of seeing this, we could actually use the circuit symbols, the diagram symbols. Okay, so notice that when I have it like this, okay, it's using those circuit symbols that we learned about last class. So it's got this, it's got the switch here, that's just two dots. It has two batteries, long, short, long, short. Here's my light bulb and here are the wires, okay? But I think it's just more intuitive if we go back to this one where they use the real life sort of real life pictures. Okay, so let's just do some examples of some bad circuits. Okay, so I'm gonna reset. Okay, I'm going to reset everything. Another example of a bad circuit is if I put the batteries this way instead, okay? So rather than doing negative to positive, let's just say I put positive to positive, okay? So notice that usually when you put your batteries into the toys, you don't line them up this way, okay? Let's just see why that is. Okay, so I'm going to just do this again. Okay, and again, you can try this out on your own as well. Okay, so please feel free to play around with this program. Once you get a hang of this, it's really quite fun to try it out. Okay, so let's check it out. Everything is connected together. There's no red circles, which means that things are disconnected. And notice that, hey, my circuit does not work. Okay, why? Because the batteries are oriented in the wrong way. It's supposed to go negative, positive, negative, positive. Okay, so let's just practice fixing our circuits because it's very often that when students are doing these electric circuits and trying them out on their own, it's really easy to make little mistakes here and there, okay? But that's part of the learning process. So allow yourself to make mistakes, no worries. And if you can't figure it out, like why it's not working, don't worry. I just recommend that I don't want you to get frustrated, right? So what I want you to do instead is just reset it if it's not working properly and you've tried to fix it, okay? But let's just try troubleshooting this. So we know that the batteries are the wrong way. So I'm going to disconnect this part and disconnect this part because I have to turn it all the way around. Okay, now I'm going to re-click it in place. There we go, we're good. Okay, let me just try out something else, okay? Let's just try out, for example, I'm going to cut this one right here. I'm going to just delete it. So if you click on the item in the middle part, okay, and you can click on this delete, like the garbage can to get rid of it, or you click on delete on your desktop or your keyboard, okay? This is another example, for example, of a bad circuit, right? Notice that the light bulb isn't lighting up. Why is this? It's because the circuit is incomplete. We have to have it all in one loop, otherwise it will not work. Okay, how do I remedy this? How do I make this a good circuit? Well, I don't need to make it a perfect rectangle, which I like because it's just more organized. But what I could do is just flip this over to here. Okay, so notice that as long as I've connected everything, it will work. Okay, so it's going to be a really quick quizzes online assignment. I'm just going to have some pictures of good circuits and bad circuits, and you're just going to tell me if the light bulb will be on or off. Okay, so please, before you try the quizzes assignment, do actually, if you can, right, if you're able to run this program, try this out just because I think it's pretty fun. Okay, another thing that you could do is like, you could also like have some fun with this by like putting in like a lot of batteries. That's always the thing that students love to do. So if I go like this, take a look at this. Look how bright my light bulb gets. Okay. The other thing you could also do is like take like a lot of light bulbs and put them in, which is pretty fun as well. Okay, so for example, I've got 5 light bulbs here and I'm just going to connect them together. Notice that they aren't as bright though, right? When you have more of these one after another like this, they're not as bright. So please feel free just to try this out. Okay, try it out and just have some fun with it. And then once you're done, go to the online quizzes assignment. So I'm just going to go back over to here, okay? So you can click right on the link that's on your PDF, and that will take you to a direct link that will automatically update me on your marks, okay? Please sign in with your TDSB email account, okay? I hope you have some fun with this simulation program, and you learn a little bit as well, okay? Okay, everyone, that's it for now. Take care, and I'll see you on the next lesson. Bye-bye.